Okay, well thanks for checking out my video. As you can see, my PROVerXL is no longer a 4030, is now a 1010. I expanded my machine. I got together with a couple people on the Sane Smart user group on Facebook and just trying to figure out what we needed to do to expand the machine on our own because we were tired of waiting of Sane Smart to come out with the expansion kits. And I know for the last couple months they were supposed to come out, so we just decided, put our heads together, and came up with a parts list and a way to do it on our own. So I know it's a little after the fact with this machine already being put together, but I can explain it to you fairly easy on how to do it. If you remember putting the machine together, it's basically the reverse process plus a little bit more, so it's not difficult at all. It just takes a little time. So with that, I'll just get into it here. So first things you want to do is when you're going to take your machine apart is you remove your stepper motors, all four of them, the Y or the X, the Z, and the two Y stepper motors. And you just need to be careful with the when you're removing the collars that are in between that connect the lead screws to the stepper motor. You can see this one right here. This is the stock one that came with the machine, and after I put the machine back together and expanded it, those collars, you can kind of see they started to pull apart, and it messed up my spoil board that I was trying to drill a hole pattern for. You can kind of see right there where some of the holes are a little elongated and not in line with the others. I had to replace this one here on the X, and I had to replace the one in the back corner back there for the Y because those collars kept coming apart. After you mess with them a little bit, they just don't hold together very well. So I went and replaced them with these all metal one-piece collars that have a little bit of like a little spring torsion to them here in the center, where they're actually one piece together, but they do flex and they won't come apart. So that was one thing I did, so just something to be aware of there. So after you take your stepper motors off, take your spindle motor off, and remove all the drag chain parts here and down here. And then what you're going to do next is you're going to come around to all the corners here and these blue corner connector plates, and you're going to remove all these screws. And I would just advise this from my experience, whenever you remove screws from a certain part, I'd either put them in a baggie or maybe put some masking tape and tape the screws to those particular parts, or in maybe a Tupperware bin or something that you can kind of easily remember what screws go in what part, because there are a lot of different sizes. There's several different sizes of these M5 or M6 screws here that go in. Certain lengths go in certain holes. So just a tip as far as keeping track of things when you remove everything. So like I said, you'll remove the corner brackets, and then that'll free up the side rails and the front rails from each other. And then from there, you're going to remove the gantry arm and support from the machine. So basically you're going to come in here, remove these screws here, remove the drag chain, little attachment clip there, and also the one in the back there. So just disconnect all your wires. Disconnect the drag chain, and then you'll pull all of your rails apart. And then where I started with next is I also removed this blue plate from the X rail here. And then once you have that off, you're going to pop off these little clips. I have one here somewhere, but there's little C clips that go into the end of the screws And there's the C-clip right there, which basically adds a little extra tension and security there for the stock screw. So you'll remove that, and don't lose that, because you can put them back on, but I didn't put them back on, and I'll show you why a little bit later. So after I got that removed, and yeah, so I got that, and then basically you're going to slide off your carriage wheel assembly here. You can slide them off. Well, actually, you'll take off this plate here first, and this silver plate right here. So you'll remove those, and again, either M5 or M6 hex head screws, cap screws. So you'll remove those, and then you'll be able to slide off the wheel assembly. And once you have everything disconnected, they come off pretty easily. They just pull right off. So then you're left with these plates here. And this is a new plate that I put on, and I'll get to that in just a second too. So then basically, after you have everything apart, then you can kind of see that this is the old front rail, the back rail, and then this is one of the sides. So I expanded my Shim with 1000mm rails, both front and side. So it's considered, I guess, a 1010 or 1000 by 1000mm machine, which gives you a cut area of about 32 inches on the X axis and about 31, I don't remember exactly, on the Y. But you can also eke a little extra inch out of the Y if you can actually overhang your material about an inch here in the front. If you're just doing, you know, a surface cut where you're not cutting the whole way through, you can overhang it and gain an extra inch or so out of the front. So like I said, once you have everything apart, this is pretty much what it looks like here. After you get your wheel assemblies off, you're going to have to remove your lead screw and nut block, which that's basically what that looks like. So there's two screws there on the plate, and then basically that sits on that would be sitting on top of that. So you'll remove that and remove the plates. Now what I did in order to get the new nut blocks in and the new lead screw in, which is right in there, that is an T8 8mm lead screw, and these old ones here are 10mm. So you're going to need a new plate. You could possibly drill into this old one to make the new nut blocks work, but I just decided to order new plates. And this is kind of the screw layout here. So as you can see, I left the bottom, or the original screws that came with these plates on the bottom, and then I put new 55mm screws up top, because it just seemed like these stock screws were not biting in far enough and holding securely enough. You could use Loctite or something, but I just decided to get some longer ones just to put in there. Now now you can't really see the nut block. I do have a picture of the assembly that I can put in the video, but you can kind of see right in the center of the screen there is a nut block on the lead screw. This actually gets two separate nylon nut blocks, one here and one here. But before you put those on, you need a spacer there and a shim that goes on each one of these 4 screws, so that way your lead screw lines up with this center plate right here. So you need those spacers to go in, and these are 20mm screws here. So each one of these screws, like I said, gets a spacer and a shim, and then your nut block sits on top of that, and then a little nylon lock nut that will go in to secure everything. So once you have that done, then you can slide this assembly, like this will slide back on here, even though that's kind of at an angle right now, but just so basically you would slide this back on. So that would go back on with obviously your wheels in between there. and then you can slide it back onto your new side rails and your X and your Y rails. So that's fairly simple. And then you just thread the new screw. This is the old one, but you would thread the new screw through the nut blocks. And then back in, you can reuse the existing bearings that are in here. You can kind of see that fits nice and tight in there. That's the old one, or that's the old bearing with the new screw. And then if you want, you can put the C-clip back on there. But instead of that, I don't know if you can kind of see it in there, but there is a lock collar on there. You can probably see it better over here on this one. There is a lock collar and a thrust bearing there, and I have that on each end of each lead screw. So there's 6 total, and you see, kind of see one back there. There's also one back there. So once you get the lead screws in and the wheel assembly gantry plates on, you're basically going to just reassemble it the way you took it apart. And I don't think there's really too much else to do. Like I said, you just make sure you don't lose any of your screws and parts, and remember what screws came from which one. One thing to keep in mind is, like I was saying, with these newer screws here, these are a little bit longer than the stock screws. And so like I have on here, these spacers and the existing wheels, I left that on, or you can buy new wheels if you want, but it's not necessary. But you can kind of see I put the new screws in there just so that they would bite better into this plate, because once you remove these old screws, you can see they're kind of worn a little bit, and they're just not long enough to get a good bite because they don't go the whole way through the plate. So I used 55mm screws, and I'll put that in the parts list, and then it just helps you to get a good tight system here at the top. Now the bottom ones I didn't replace. The bottom ones I left the stock screws in. They just seem to work better in the bottom, or work okay in the bottom. So I left those in. They were biting okay, but the top ones were not. So that's why I replaced those on all 3 gantry plate assemblies, or wheel assembly plates. So see, what else did I do? Actually, here you'll see the drag chain. Since everything is longer, your existing drag chain on this axis here on the axis is not going to be long enough. So I connected the 2 stock ones together, so that way it would make one long one there on the top. And then I bought 2 more off of Amazon. I think these were $18 here for these 2, and that's almost the exact same size. Might be off by a millimeter or something. And I used that for the Y assembly drag, or connecting wires. You could use something like this little plastic tubing here. That's what I originally bought, and it worked okay, but I just wasn't happy with it because it just doesn't flex as much. I mean, it flexes, but it just doesn't look as good, and just didn't work the way I wanted it to. It doesn't work the way as the drag chains. So as far as the wiring is, you shouldn't need new wiring. Everything is long enough, but there are some areas where it's a little tight, like up here. These connectors were a little tight, so you just got to make sure that you give yourself plenty of slack before you run everything through the drag chains and reconnect everything, because you don't want it to disconnect while you're running the machine. So let's see, I can point out another thing. As you can see here, now with these old rails, I use those as a template, and I'll just grab a piece of extra extrusion, because you can kind of see that they have holes in and they're notched. And they also have holes in the top for the spoil board, but that's not as important. You can drill those out and use a tap. But for these, for the new rails, basically what I did, sorry for all the camera movement, but I just basically laid the old one on top of the new one, marked the location of the holes, and this notch right here, and I used that as a template, and I did that on each side of the new rails. So that made it pretty easy. And then just one thing to keep in mind here is that the new rails, now this is just a scrap of that I had laying around, but the new rails do not come tapped. So you can buy a tap set, which I did, and I bought a cheap one off Amazon, which don't do because they break very easily, and the threads, and then this one here also, if you can see it, the threads on the end of this tap just got chewed up. So it's not a very good one. I think that was like $10 or $15 off of Amazon, so don't do that one. Just buy a decent quality one from Harbor Freight or Lowe's or something. It might cost you 30, 40 bucks, but it can save you some headache. Or also what I did is I used a 5/32 drill bit to go in with these screws here, or also it'll work with these black screws if you just drill into the ends with this 5/32, which I think I already did on that one. So you just drill into there. You can even use one a little bit bigger if you need to, and then you should be able, with a little bit of 3-in-1 oil or something, if you just lubricate the screws and take it real slow, you should be able to just thread into the new holes with either the tap or one of the existing M5 or M6 screws. So just to keep that in mind, because like I said, all the new extrusion that you're going to buy does not come pre-threaded. Like this here is one of the old Y rails, and you can see that does have the threads in it, but I guess they did that when they manufactured the machine. So but again, the new ones will not come threaded. So again, basically the assembly process is just, or the disassembly process is basically the reverse of when you put the machine together after you first got it, plus a little extra steps. Now, time-wise, it probably took maybe a half hour, 45 minutes to get everything apart, and just to kind of organize all the parts to make sure I wasn't missing anything or didn't lose anything. And then probably another hour or so, hour and a half maybe, to put it all back together. Now what you'll need to do also, once you do have it all together and ready to run, since these are 8mm lead screws for the new ones and these old ones are 10mm, you will have to edit your candle settings to account for the different size lead screws and the different movements, so you can calibrate the movement. And I can show you in another video how I did that, but basically what it comes down to is I just basically laid a metric like this here, just laid a metric roller down parallel here to the front of the spoil board. I put a 20 or 30 degree V-bit in the spindle. I brought it over to the edge, right on the edge here, so that you want something with a really fine point that you can get accurate measurements off of. And then what I did is I set candle to move the spindle 100mm. So then with this machine, I think it went over to 81 or 91 instead of 100. And there are some calibration links that I can put in the description, or another video, a link to another video from another channel that showed you how to do it. But those spreadsheets and links did not quite work for me. They didn't I don't know if they were made for a different size lead screw. So basically what I did again was I started here at 0, moved the spindle 100 millimeters. So then at first I think it did come up to like 81 or 85. So basically then I went in and edited candle to move it. I just bumped it up. I think it was the default setting for the machine was at 160 for the X, Y, yeah, both Y and X axis was 160. So then I just started at 160, edited it to like 165, 170, until the machine would actually move 100 millimeters. And I'm not sure, I'll mark it in the description, but I think it ended up for the 8mm lead screws, it ended up being I had to put a value of 198 in the machine in candle so that it moved exactly 100 millimeters. So you just have to adjust it accordingly. I just moved it up and started at 160, which was the default setting for the 10mm lead screw, and then I just bumped it up in increments until it went exactly 100 millimeters. So it's a repetitive process, but it seemed to work out much better than trying to figure out a formula with all the different calculations involved with the pitch and the diameter and stepper motors and all that. So the settings on the stepper motor. So I just bumped it up little by little until the spindle moved exactly 100 millimeters in candle and then on the actual machine. And then I just recorded that setting and then edited candle to reflect the new value, which I think was 198. Originally it was 160. So, and there are other ways to do it. You may find something that's more simple, but I just did it that way and it seemed to work out pretty good. And I double checked the measurements a couple times with a made a couple different cuts, and well, it's a couple different pieces, but this piece of plywood here, or this piece of pine, I just drilled 6 holes in it to make sure I set it up in easel to go 1 inch from the side, 1 inch from the front. These are 1/2 inch holes, and I think they're 1/4 inch deep, or maybe 3/8 inch deep, and just spaced them equally. And then I ran it on the machine and cut it, and everything is dead on accurate. So within I think within 1/1000th of a millimeter or 100th of a millimeter. So I'm not going to be manufacturing any precision components, so I don't really need, you know, dead on accuracy. But like I said, I think it's within 5/1000th of a millimeter or something. I can write those settings down and put it in the description too, but where I can show you another picture that I cut some other things on before and after and noted the measurements. So I don't think I'm missing anything other than just a couple things. I added a vacuum hose boom. I got and this is from the parts I think were originally noted on Thingiverse or the Onefinity site. You can kind of see these three fittings here, and then up here, and then there's also this one down here, and then this just fits a 1 inch shower curtain rod that I bought at Home Depot for about $20. So I'll link to that also. And then basically I sat that on top of a little round scrap cutout that I had, and then also put it on top of this little Lazy Susan here, so that way as the gantry moves, kind of see that just moves freely as the spindle moves around cutting, so it has full range of the spoil board. So that worked out pretty well. So again, I don't think I'm really missing anything. It's just a much larger machine than the old one, and it'll cut twice as big of an area. If you have any questions or comments, let me know. And if I think of anything else, I'll add it in the description or add a little video edit at the end. and go from there. So again, if you have any questions or comments, feel free to let me know, and thanks for watching.